Hey, CHEM 2P20 students, it's Ian Gordon, Brock Library Science Librarian, here to give you an overview for the SciFinder exercise you need to complete and hand in as part of this particular course. This particular video talks about the assignment itself and things you need to consult. There's another video that I'll show you where to get it that does the SciFinder part of it in case you're unfamiliar with it and want more information of how SciFinder works. These PowerPoint slides are archived, as well as a completed form for a faculty member I'll use as an example for this assignment, and a blank form, which also could be on Sakai as well. So check them out, and hopefully you can complete this exercise in a timely manner. Let's jump in. This particular assignment it links you to a number of activities. The objective of this exercise is to gain experience exploring the chemical literature, know where, how, and why to register for the SciFinder database, know how to create citations, naming conventions, substances, reactions, and be better informed of Brock University organic chemists' research interests, productivity, and expertise. You'll be picking one of these as well. You need to do a number of things. One is to go to the Brock Chemistry Department's webpage, and there's the URL there, and pick one of these synthetic organic chemists, including your professor. And there's about 5 or 6 here. You need to pick one of these as an example. And before you do that, you may know which one you'd like to pick. You may not know them all. You may have a course from one, or you may never have a course from one of these. Go through and look at their research publications. I'll show you where, what they do, what's of interest. Some are senior or mature chemists. They're all productive and do scholarly research and are very important people. So make sure you go through these and scan through the group's website, their list, their profile, and do a bit of browsing before selecting your faculty member for this particular assignment. It would help you to do something that's related to what you're interested in, but they're all certainly doable. Here's the Faculty of Mathematics and Sciences Chemistry people page. Here's the faculty on the right-hand side. I'm going to pick a specific faculty member that's not part of this group. But if you go farther down the page, here's a link to their research page and the Brock page that tells you about their interests as well. So again, take some time and pick the one that's most related to your research interests. I'm going to pick Melanie Pilkington, amazing synthetic organometallic chemists. There's a research interest, and every faculty member has a page that documents their research interests, their publications, collections, and the courses they teach, but also there's a website. Almost every faculty chemist, including your professor, has a web page that documents what they do, how they do it, advertising for members to join their group, so make sure you check those as well. The research interests are listed here, publications, as I said. So here's Professor Pilkington's research group. It talks about their activities, a list of citations, the equipment they use. Again, it's kind of neat. It explores more about what they do. The list of publications is here. Some faculty put all their publications here, or they put them in ResearchGate or LinkedIn or other resources, and some faculty don't, but each one of the faculty members that you get to choose from put their publications, because they're so proud of when they're actually accepted in peer-reviewed scholarly journals. They put the citations, and sometimes they put the links in, but you can find these publications in Omni by cut and pasting the title and putting it in and searching for articles as titles. If you look at here, Melanie Pilkington is M. Pilkington in Omni citations. So what you need to do is validate and verify what initials or what names do they use, because you have to search for their names in SciFinder as well. Now, some are quite obvious, and this one's pretty obvious, but some aren't. People with Asian names, common names, or maybe have changed their names. It's a bit trickier, or changed institutions, so that's part of the art of online searching, is to know what their proper or appropriate author's name is. Look at their papers. Here's one paper, here's another paper. Sometimes they're hard to read, but it gives you titles and abstracts, DOIs, digital object identifiers, keywords, gives you a sense of what equipment they use and how to answer some of the questions as well. So here's the exercise. We'll go back. So we went to the faculty page. You also need to go to the Brock Library Chemistry Research Guide to identify databases you need to search, services, journals, and articles to help fill in those guidelines as well in the paper. Here's our home page. It's dynamic, but it looks pretty well like this. It has our Omni catalog at the beginning, an advanced search Omni interface as well. You search for books, articles, streaming videos. So one all, catch all. It works quite well, but there's other databases that you can use for this assignment as well. Click on the research guides, and then when you go through the faculty pages, you bring up My Chemistry page. There's tabs on the left-hand side for books, and ebooks, and articles, which we'll look at. Definitions, meaning encyclopedias, dictionaries, handbooks. Chemicals and drugs, meaning how to find and identify and verify these sorts of things. Properties and reactions, again, this is a chemistry guide. Patents and standards are an important, great type of literature you'll learn, just as theses and dissertations, meaning master's theses and PhD dissertations. Geez, when you're doing research, you'll beg, borrow, not steal, not plagiarize, but you'll look at whatever the people are doing. If you're doing a serious capstone project, an honors paper, an important course, you want to look at all these formats, books, articles, patents, theses and dissertations, see what other people are doing or from around the world, and incorporate that into your research. Again, chemistry is building on a body of knowledge. Interlibrary loan means it allows you to get materials from other library. You probably don't need it for this assignment, but it's an important resource. Streaming videos, writing and citing, we'll talk more about that. And there's other resources as well. If you look on this front page, it tells you where to get ChemDraw, so you can download it for free. A Cambridge crystallography database to find specifics, physical properties, create, see what other people have done for crystallography. The ACS Guide to Scholarly Communications, default to Style Standard Manual. ACS, American Chemical Society, produces it for formatting and doing references. So it's an important guide. ORCID is listed here, and the citation management software, we'll talk more about that. And Cetero is there as well. There's a complete list. If you go further down this page, you'll see CHEM 2P20 SciFinder exercises. The PowerPoint slides you're watching now are there. This YouTube video is there. A complimentary SciFinder video is there. And in Google Docs Word form and in PDF, I have a blank form and a sample answer set, the one that I'm kind of borrowing with you today. Below there, I changed what's on the guide as well. These are organic chemistry beginner guides. Nothing better than taking an exam and going through, let's say, a test book, question and answer that helps interpret. These are some of those sorts of things if you're curious, if you want to go through them. There's others that are there, but these are the ones that I chose to use because I'm not a chemist, I'm a geologist by training. So going through these guides that help you to move through problems kind of help you to be a better chemist, especially from organic chemistry. So those are the resources you need to catch. They could also be in Sakai. But at the bottom of the page is my picture. There I am. My email, so you can email me at any time. Or you can book a consultation. What it does is it opens my calendar where I'm available, usually at 24 hours notice. You can click on it and find a time that works for you. And you click on it, it asks you, what do you want to see me for? You could say, I need to know this about SciFinder. Though this exercise is relatively easy. It'll take you about an hour to do. You may have questions or problems. The biggest problems I have is SciFinder is not working, or I haven't registered, or it's due tomorrow and I can't get this to work. If I could tell everyone, if you've got to use SciFinder, you've got to register for it, do it right now, because it's a problem and you can't do this assignment without SciFinder access. So you may book a consultation at any time. While you're here at Brock, some people book an appointment even after they've left Brock. How do you do that? Or can you help me with this? Or I need to find this. So I'm always available as long as I'm at Brock. Glad to help. Here's the first question. Name the researcher to be used for this exercise. Write out variant spellings. Remember we saw M. Pilkington and Melanie, so we know there's two. Does this researcher have an ORCID? That's how you pronounce it, ORCID ID. So here's the website. We'll talk more about it. If yes, please include it here. And it asks the question, have you registered and created a personal ORCID ID? I mean, you yourself. If yes, please indicate it below. If not, I say do it today, it's free. So I went to ORCID and I searched in Melanie Pilkington. Again, you'll know whether your name is popular or common. My name, Ian Gordon, is a very, very common name, but there's Asian names that are very common. You'll know by searching Facebook and looking around the world whether your name is important. And it's a common name. So you want to differentiate that. ORCID is becoming the international standard. If you do a research grant, if you apply for a job, you should have an ORCID ID and put it on your resume and on your form. What it does is it validates that this is who you are. Like gives you a number, like a social insurance number, but it's an international standard. Even if you don't pretend to be doing any research, you don't know where you're standing, apply for your ORCID ID now, because what it does is it helps you to evaluate and to include what other people have done, but how to differentiate it and provide a unique name. You may want to include two names, your first and middle name and last name, a initial or two initials. It differentiates you from other people, and you save that ORCID ID number for the rest of your life. It's a database increasingly that people will ask you for that. I'm sure in the near future, what is your ORCID ID? And then you can turn it on or off. This one has been turned on, meaning there's a biography there. If you go down further, Professor Pilkington has listed all her publications. If it's not turned on, it just gives you your ORCID ID and your name. So is it on or off? This one's on. So here's how I completed the question. I found by looking through and browsing and looking at the publications, is Melanie or M. Pilkington. I didn't find anything else. Does this person have an ORCID ID? Yes. I put it in there, and I already have an ORCID ID. You can look for mine, but if you make yours today, put it in there. Curious to know what it looks like. Next question is consult this faculty's research profiles and publications, and Web of Science database publication keywords. Kind of look at different databases to document 5 keywords or phrases that best describe 1, the chemistry subject areas or topics that this person researches. So 5. You can put 4 or 6, but I want about 5. Substances, classes of compounds. So you know how to speak chemistry. You know the paradigm. You know what words they use. What sort of classes of compounds do they investigate? And 3, well, I want to know what instrumentation or equipment that they use as it relates to organic chemistry. They may use 10 or 20 or 30 things in their lab, farm out to do this and this and this and that, but I'd like you to use 5 keywords or phrases that best describes the equipment that they use as well. You only look at this by browsing and looking at the person's research, their website, and the types of publications they produce. So here's again, for Professor Pilkington, keywords or phrases: coordination, inorganic, organometallic, molecular magnetism, and superconductivity, I think is the top areas of research that she does. Classes of compounds, you can read them there. MOF, SIMS, thin films. I put more than 5 because I thought they were all important. And the instrumentation they use, whether it's at Brock or she uses other expertise at other places. X-ray crystallography, huge, important for inorganic chemists. X-ray diffraction, NMR, UV, EPR, and ESR spectroscopy. So I want you to fill that in as well. Question number 3, 10 questions to go through. Follow instructions in the Brock Library's Chemistry Guide under the Articles tab to register for SciFinder account. Remember I said you have to register for it, so do it now. It asks you to confirm who you are by email, like most databases, and then you need to sign in each time you want to use that database. It's one of the few databases at Brock where you need to sign in, and it's your database, though you get access to it because you authenticate at Brock University. So you authenticate through the Brock portal, then you authenticate at SciFinder and put in your own unique username and password. You make it up. What I want you to do is when you find that username, I want you to put it, validate that, and I'll show you how to validate it. But there's lots of resources, introductory YouTube videos, duplicated in the Chemistry Research Guide to learn more about how SciFinder works. So you can click the one on references, one on substances, or reactions. Gives you a better sense of how this works if you've never used SciFinder before. So go to the guide. There's a link there. Certainly look at the videos, but answer the questions here. So this is how you would answer this question. Pretty easy. Go to the Articles tab. Under Articles, there's a number of articles that are here. It talks on the top about other tools that you could use, but Omni is there because it's our go-to database, and you may have used it before. Lots of people use Google Scholar. Reaxys is a database that most chemists use as well. Web of Science is a database you need for use for this assignment. PubMed, Embase, Jesus, more databases. Wouldn't it be nice if there was one database that did it all? But really, other databases provide access using their subject discipline. Usually the core articles are duplicated in all these databases, but sometimes each database has unique content that can only be gained by searching that one database. Then at the bottom, it tells you Brock Library chemistry databases, the news databases, the patent databases, because there's more than one, and the occupational health and safety databases as well. In the middle of it, here's the SciFinder page. So it asks you to register. So go there and register. It asks you who you are, what you're doing, an email address, make a username and a password. So make it so that you can remember as well. Though there is I forgot my password key, or you could email them and ask them to validate and verify. But remember that username and password. You make it up. Register. And there's more videos that you can watch here that I thought were important. So when you log in and authenticate and click on SciFinder, it asks you to log into SciFinder. That's who I am. I put in a password. But why would you want to use SciFinder? Well, for this assignment, it's important to gain this soft skill of what it is and how it works. It's an industry, academic, interdisciplinary standard database for chemistry. You got to use it. It actually includes Medline. So when you search SciFinder, you're searching Medline as well. You can turn that off and on, but it uses their subjects and their keywords. And there's overlap between the chemistry and medical sciences database. But for an applied health sciences, people who are wanting to go into medicine, it allows you to search Medline in a different way. You can always get expert help by phone or email. It's free. I do that when I can't get it to work, or there's an error, or I want their help to working through a synthetic organic synthesis. They're experts with PhDs at the other end that can help you. Since you have your own username and your own account, you can run alerts or keep me posted searches, meaning you find research by an author, a research group, in a subject area, a series of keywords, or a reaction sequence, or compounds, or a pattern you're trying to follow. And what it does is you tell it to run this search as often as you want. I let my searches run once every week, and then have me email me the results with links to citations so that I can see what other people are doing. It's called an alert because it keeps you on track. And when you may get your first job in chemistry or biology or in applied health sciences, this is one way to search the chemical literature to find out what's going on, so that you can inform your research group or be on top of things rather than wonder, is there anything new this week that I need to look at or my faculty member needs to look at? But since you have your own account, you can run reports. You can make a group account for your own research group. You can save your histories, but it's all for free while you're at Brock University. You can import and export search results. Again, there's a link to Brock Holdings, so you can link to all our full text content for all our journals. It includes dissertations, meaning PhDs. It doesn't include master's theses, but includes patents, which are hugely important, reports, and conference materials. It's a property database as well, so not only can you find chemicals and substance reactions, but you can find physical properties, spectral properties, again, only through this particular tool. Most importantly, and increasingly important for synthetic organic chemists, it allows you to search by structure or substructure, meaning you can search by a chemical compound and say, I want this or that, or not this or that. And we'll go over that, but that's what makes this database unique than all other non-chemistry databases. You can track chemistry and all bio-related, like biochemistry, bioapplied, and engineering fields as well. It has a wide swath. It works with citation management software, so you can send all your results and keep track of your citations and PDFs using Zotero. It's a small chemicals database, so it allows you to verify, identify, allows you to get commercial suppliers that try to sell you how to get materials, because often bench chemists go, do I make this or do I buy it? What's easier to do? So it gives you those links as well. And it's also useful for naming conventions. Like me, I can't name anything in chemistry. But most importantly, it's a soft skill to put in your resume when applying for a position. Not only do you have an ORCID ID, and it's right there, but you can say, I've used SciFinder, I have an account, and I understand how it works within this particular research area. Excellent start to a conversation, because most people don't have a SciFinder account, but you will because of this exercise. So here's SciFinder. It comes up and asks you to search by different ways. It'll also prompt you to use SciFinder N. Don't do that, but sometime this term or early next term, we move to SciFinder to SciFinder-N. Same database, it just has a different look and feel. You can see on the right-hand side my saved searches. I have one on Pilkington and Zalesko. I have one on Brock. See where it says keep me posted on the right-hand side? So I run a search of anyone at Brock University in the publications that hit Medline or SciFinder. I look at them just to see what people are doing. On the left, it allows you to search by, like any database, by author, by title, by document identifier. And it allows you to search by three groups. Research topic, that's like a Google interface. Author, company, substances, again, chemistry, by structure, molecular formula, or substance, meaning I want to search by this chemical or class of compounds, and it does reaction searching. So that's what makes SciFinder unique. References, substances, or reactions. You can jump from one to the other. So you can start doing a research topic, find a series of chemical structures, and end your research with reaction sequences. Again, every citation in SciFinder, there's 5,000 added a day. 5,000 added a day. Links to a dissertation, most of articles, a conference material, or a piece of material that's scholarly peer-reviewed research. What I need to do for this exercise is see where it says welcome Ian Gordon. I need to validate and verify that you have a SciFinder account. This is one way to do it. You cut and paste, or you do a screenshot of this particular. So when you answer the question, answer question 3, it says welcome Ian Gordon. It has your name there as well. Makes sense? So 10 questions. We've done 3. Pretty easy. Let's jump into SciFinder. Well, I won't do that here. I'll just show you screenshots of things, but you need to search for this author or this researcher, one of the ones that will be given you in chemistry and faculty members. I need to know the number of references for this researcher. Remember these initials and names. It may vary. Click on the SciFinder categorize. You can do a number of things that you can do to answer this particular question. So we're looking for a number. I want to analyze in the database. Though in most databases you analyze by, you only want things in English. You want them in a certain date range, and you want them in a certain format, meaning just an article. Well, in chemistry, there's so many more variant filters that you can use. One of them is analyze the database to just chemical abstracts, CA+, as opposed to Medline. You can refine by document type. I just want a patent. I don't want articles. It could be 0, so put a 0 in if you don't get anything. And you can limit all this author's publications by the number of substances that they have citations for, or the number of reactions. And so this is what it would look like. So I went in and look in the top, it keeps breadcrumbs, so it tracks how you're doing. So I put in author's name, references. I found 151 citations in SciFinder for this particular author. I analyzed by database and I found CA plus 104. So that was the answer to my question. But then it lists in whatever order by usually a reverse chronological order, the most recent to the least recent paper or dissertation or conference paper, and it links it there. I picked on this particular article, and there's a title. There's a list of authors, like any database, an abstract, and information. It's a really neat graphic they have there as well. But on the right-hand side, it tells you where they got this from. So it's in the journal Inorganic Chemistry, the volume issue, the DOI, or the Digital Object Identifier number that's unique to this particular article, and where it funds, and it tells you it's a CA+, or it's a chemical abstract, so it's not a Medline article. It links link to other sources. I can get the full text copy, read it, and download it. I may say, I don't want to look at this, but you can click and link this, and you can do other number of things. You can mark your records and send them, email them to yourselves, or you can send them to a citation management system as well. Here's a citation management system. So here's the ACS style citation that needs to be incorporated into one of your articles as well. So in this article, there's a number of indexing concepts. So I identified, they're in blue, 1, 2, 3, 4, 5, 6, 7, I think it is, concepts. So what it does is it takes this article and puts it using standard nomenclature for all subjects and uses a standard text so everything's spelled appropriately. And these are the words that describe this article. Amazing, all this research, all this article, and these are the words that index it. So it's a standardized language. So you never have to wonder, is it teenager, adolescent, or high school student? What words do they use to describe certain comments? Well, in chemistry, in SciFinder, they standardize the terms they use so that when you find one thing, you can find other sorts of things. And then in SciFinder, these are clickable links. It includes the substances used. I mean, it doesn't include every substance. They may have used 1,000 substances for this one article, but it includes, and you need to count these 1, 2, 3, 4. I guess there's 30 or 40 of them here. And it tells you what clickable links they are, and they use CAS reaction numbers, CAS numbers. So these are numbers for each compounds. And again, this describes what they've done in this article. And then at the bottom of this citation, it includes the cited references that they've used, meaning they're building on a body of knowledge as they cited these articles in this particular paper as well. So to answer this question, I found 151 for this author. I analyzed by database. I found 104 of them were in the chemistry side. I found one patent when I limited by document type equal patents. And when I went back to these 151, meaning you got to go back to the top, limit by get substances, of the 151, I found 1,042 substances. Isn't that amazing? Now, when I went back again to this 151, I says, how many get reactions? So there's 1,664 reactions based in these 151 citations by this one researcher. Your researcher will have different numbers. They may be big or small, but these are the numbers that you need to pull and insert into this Word document and then hand in as part of your assignment. So that's question number 4. Question number 5 is a bit the same. It allows you to explore a different part of SciFinder. So it says go to SciFinder, look up that author name, but limit by get substances, retrieve all references limited to preparation. sort the references, and find one organic or organometallic chemical structure of personal interest. Note that this substance must be organic, commercially available, and complex enough to be somewhat interesting. I'll go over that in a minute. And then fill in the form. I want to know what the IUPAC chemical name is, CES registry number, and molecular formula. And then I want to put a screenshot in here of the substance. So if you jump in, again, it has to be organic and commercially available. So I did look at the top. Pilkington M, those 151 references, you'll get a different number. Then I listed get substances. There's 656 substances linked to these 151 citations, or mainly articles. And you can sort them by number of references, by complexity, by size. But if you look at each one of them, the CAS registry number is on top. So it's like an encyclopedic entry for each one of these chemical compounds. Here's the one I picked, number 21. I think there's 44 pages of these. And so complex enough. The number on the side, the 11518, tells you how many citations are in SciFinder. So the more the better, but you don't want to pick water or methane or something like that. Find something that looks interesting. And it tells you there's around 116 commercial suppliers that will help sell this to you. Another way of finding it. So look at it and browse through and find something of interest. I thought this would be interesting. I pull up the page by clicking on the number, and it tells you how I got these. So the CAS registry number is 103-29-7. More numbers, but this is what's used to validate and verify. So here's the encyclopedic page for this one compound. It tells you the IUPAC name. It's just under the molecular formula. And then further down, links to spectral data, M&R data, all other physical properties as well. And it gives you a clickable, so you can include this and put this into a structure search of that particular compound. So here you go. Answer to question 5 for me is there's the, I won't pronounce it for you, IUPAC chemical name, the CAS registry number, a unique number for a unique compound. And there's about 5 million chemical structures, of which maybe 10 to 20,000 are commercially used on a regular basis. So there's lots of numbers. Find the number that works for you, and the molecular formula using the Hill system, meaning that's how you write it as well. And I cut and paste and put the structure there. So that's how you answer question number 5. We're halfway home. Question 6 is take the substance, so you've got it, and go to PubChem, which is in the NIH, or National Institute of Health in the United States, and search this compound and find the compound CID number. So you go back to the chemicals or drugs tab on the chemistry research guide. And there's about 40 of these because they're all important. They all do different things. And halfway through the guide, there's PubChem that's listed there. You can just go right to PubChem. Most of these are bioorganic, pharmacological, synthetic organic chemistry tools, like the Merck Index, Mosby's, the Orange Book, Pharma Guide. But PubChem is really amazing and it's free. So I actually went to the database, and it allows you to search by structure, allows you to search by chemical formula, by name. I put in the CAS registry number because it's unique, and it takes it. And you find that most appropriate compound. You don't want salts, stereoisomers. You'll know which one works best. And you click on it, just like in the CAS registry, and find more information about it. But again, we want the number and that compound. So for this, it's pretty easy. Put that number in, 7647, and I click on the link, which is at the top of the page for this. But make sure you check out this database. It's truly amazing how much information is there, and sometimes it's a go-to. And again, since this is the National Library of Medicine, it's a free database, and then you can link to PubMed and search using the chemistry part to search this database as well. Truly amazing. Question 7. Go back to SciFinder, explore by substance identifier, not by author name, substance identifier. Get that substance we did in the previous question, then click on Get Reactions, limit to product, and we want to find journal articles, so you analyze by document type equal journal. You can sort them and look through them. You can analyze them by yield, by reaction sequence, by solvents, anything. I refined by a reaction classification, and I picked up biotransformation, which is kind of interesting. You can choose any one you want, sort the records, but you need to find one organic or organometallic reaction sequence of personal interest. Now you go, how can that be interesting? Well, look at something that's interesting. Click and view the details, then link to the source, then answer these questions. So again, every chemical compound, every reaction is linked to an article, a patent, or a thesis or dissertation. So you need to move through this. So here's what I did. I found that substance, I put it in. There's only one substance that has this CAS register number. And then I clicked on Get Reactions. There's 3,076 reactions that you can look at. And then I refined. I only wanted to, you can analyze or refine. The thing about SciFinder is when you refine or analyze, analyze is you want to see what's there, where refine is I know what's there, I want to filter, and I want to limit my results. But you can do both with each. They have different types of filtering, and you learn to know which ones work best and which ones you want to get good answers for as well. So I looked at how many of these deal with biotransformation. There's 19. And again, they're always linked to a source as well. So here's the citation. And I said, this looks interesting. And it tells you the number of steps, the notes. Sometimes it gives you like a recipe for it. But it's always linked to an article as well. So there's the citation of the article. And it's a clickable link. So when you click on it, it brings up this information. Here's the article in SciFinder, and so it gives you a title, a number of authors, abstract, and again the source and where it's from as well. Indexing, remember we saw this before, how many indexing concepts? I see 1, 2, 10 or 11 of them there. They're the ones that are in blue. These are the subject areas for this one article. The substances, count them. There's 1, 2, 3, 4. You count them all. That's what they used to describe this one article. And then supplementary terms are there as well. So they're kind of neat because that's what the author used as well, just not what they used. And the number of citations at the bottom of it, you can count those as well. So when you go back to your page, I put the reaction sequence in. It's a CA plus record. How many substances we found, how many authors, how many concepts, how many cited citations are there, 43 at the bottom of the page. Then I want you to go to Web of Science core database. I cut and paste that title or the DOI and look in the database because I want to know how many times this article has been cited in that database since it was published. You can do that, and then I went down to the bottom and I put the citation that's there as well, and I pasted it as well. So looking for numbers. And I actually looked at the article as well. It's kind of interesting to look at as well. Again, Web of Science, how do you get this? Reason why Web of Science, because SciFinder for now doesn't give you cited references. So let me show you how that works. So I went back to my Articles tab. I looked at Web of Science Core Collection. I clicked on it. I cut and paste the title or the DOI or found the article. Usually they're always here. And it tells you not only how many times references they use, 43, gives you the same information. You can't search by structure here, but it give you most information you need to know. But it's been cited twice, and you can click on that. Like, who has cited this research? Another way of tracking, not only of what subjects and structures and reactions that people have used, but it also tells you how many times other people have looked at it for whatever reason. Another way of tracking the literature. Note sources for helping and writing. Citing and tracking can be more productive on the chemistry research writing and citing page. There's a link there. Do you use a citation management to document references? I mean, do you know APA? Do you know MLA? Do you know Turabian? Every discipline uses citation formatting style. Well, in chemistry, they have their own. They use the American Chemical Societies, or CAS or ACS, because it's a standard that's used and it's kept up to date. It's kind of different. You can see it in chemistry publications, and so you should understand how that works. What I tend to use is a citation management system of Zotero to do that for me, rather than trying to figure it out myself. But you don't need to do this. I just want to show you how amazing this is. So here's the document that I have. It includes a title and author, a number of authors, and it includes a DOI that's usually near the top or near the bottom. There it is. This one looks like this. All current documents that are scholarly peer-reviewed articles do. And what I did is I created this. Sometimes you have to change it since it's not correct, or just tweak this or underline that or bold that, but that's what an ACS style with titles looks like. You go to the Writing Citing tab of the Library Chemistry Research Guide, and it tells you all these tools. There's common tools that you've used like BibMe or EasyBib, API guides, but the ACS Guide to Scholarly Communication is a default standard people use now to know what style to use. But then I put cheat sheets in, like from Murdoch University or Williams College Libraries. These are quick and dirty style guides, usually for journal articles, and so I depend on those. Or just go to Google and how do I do ACS for a patent or an article or a dissertation. Zotero is listed here because I use it and teach it, and we do workshops for that as well. And it gives you links to know how to do that. Check it out. So this is my Zotero account, which works on my PC. I also have a cloud account and a CHEM 2P20. Every time I saw an article, I sent it here free, and it downloaded or included automatically the citation for this particular tool, the abstract, the date, the authors, all the information here. So I could have 1 to 2 or 100. And if you're the junior member of a chemistry research team, not only do you not know how SciFinder works, you run the alerts, you see what's going on. You also keep track of what's going on. So you could have a group Zotero account, which everyone contributes to, but it's like your memory for this particular experiment, this particular course, this particular assignment. And what it does is it tracks those and keeps those as you move through, so that next year you go, what was that paper I looked at? Or what was the bibliography? You can recreate it or find that information by searching this Zotero database, which is yours and yours alone. But most importantly, what it does is it takes the citation or groups of citations. I click on, I want to use ACS style as opposed to another style. I click on OK, and it creates the citations automatically for me. Isn't that amazing? So investing in Zotero or citation management style, usually when you join a research team, you ask, what citation management system do you use? There's several of them to use. You could say, if you don't use one, this is the one that I would want to use. And there's that guide there. Cut and paste, put it into my essay or this form. Digital object identifiers, which help identify things. They identify figures and groups and graphics and sometimes images, but most importantly for articles in scholarly peer-reviewed journals. So it asks you to co-find this article published by me and put in the DOI for this. I'm not giving it to you because you have to find out what it is, but it's a unique number that there's only one of for this particular article. And here's the article that you find it. So how do you find this article? Well, some people cut and paste the title and put it in Google Scholar within our own domain and it finds it. Or you could search Google, but some people just take the DOI, which you'll find, and put it in, and that usually finds it itself. Never pay for anything. If you can't find it, ask us. We can help you to find it. But more times, 9 times out of 10, every article that you find in SciFinder, we probably have in full text format. So find the DOI for this particular article. The ACS guide is here. Check it out. It's a link here. I want you to watch this peer-reviewed too. What is a peer-reviewed article? It's 1 minute and 46 long, and I want you to look at the article you cited in the next to previous question, what they had to write down the citation for. Is this article peer-reviewed? Yes or no? Then I want you to answer the question in one sentence. How do you know? Okay. Question 8, we're getting there. There's a number of databases that you could use. I want to search by not only author or research, I want to search by structure as well. So it asks you to go back to SciFinder, explore by substances, click on chemical structure, look at the structure editor, draw or import the structure for that chemical compound, and then filter it, and how many substances. So it's a number you're looking for as well by refining it. I'm going to use the chemical compound that you used. You have yours. And what I did is I went into SciFinder, and this is another thing that may be a problem. Not only does my SciFinder account not work, you need to figure that out quickly, but the editor doesn't work as well. Just because of a number of filters or whatever I'm using, you need to figure out that this works as well. So test this as well. So you can draw this chemical compound, but I can't draw. So I click on the T, download, I import, and I put in the CAS registry number, and it automatically inserts it. Then I click on search by structure, exact structure, and click on OK. Pretty simple. But then you could search this if you're looking for an answer to a question by blocking off this ring, allowing substitution here, not here, these classes of compounds, looking at, so there's a number of things you can do. And that's what a synthetic organic chemist does. They search the literature not only by author, by keyword, by reaction sequence, and by compounds, but by varying the structure to see what other people have done, to see what's doable or not doable, what's done and what's not has been done. So click on OK and answer that question. The last 2 questions before I go is comment one thing you've learned about the nature of your faculties, this chemistry faculty members' research profile through this exercise. One thing you learned. 1 sentence. Question 10, pretty simple. One thing you've learned about SciFinder, chemistry databases, and the nature of chemical information through this exercise. One thing. Not that it's neat, or wow, it's big, or it's hard, or SciFinder is one of the databases, but one thing that you can speak to the nature of the research, the type you search, and how it may be different than what you've done in other particular databases or in other courses. So here's the things. You need to go to the Department of Chemistry Faculty Research Profile, select a faculty member of interest, take time to do that. Create an ARCAN ID for yourself. Gosh, you got to do that. Go to the Library Research Guide for Chemistry. Make sure you register for SciFinder. Test it. Make sure it works. Check the structure editor as well that it works. It's downloadable. But always remember your username and password. But if you forget, you can contact them, or there's a you forgot your password option that you can use as well. Consider registering, downloading, and using Zotero. Oh, gotta use it. You'll use the Web of Science database. You may use Google Scholar or use the Omni database to find the article you're looking for. Pace yourself. You may want to do 1 or 2 or 3 questions, then tomorrow do 2 more. Don't do this at the last minute for sure. It takes, I guess, an hour, I would say. Watch the embedded videos like on Peer Reviewed and SciFinder. Check out the other SciFinder video that I've done as well. And ask for help. You got to be proactive. Ask a Librarian chat is on our homepage. It's available most days and most nights and on weekends. So quick question is, this isn't working. Can you help me with this? Email libhelp@brockview.ca. Someone will get to you during the business day. Or book a consultation. Now, don't book a consultation because you haven't figured things out. But if you need real help or you're just lost, I can help you with that as well. Or email me. Think like a chemist. That's the big part of this exercise, is how to think like a chemist and use this database to your advantage so that when you graduate or move through this course, you'll be familiar with not only scholarly research as it relates to chemistry, but the tools that you will use in the future. So where to get help? It's the last tab. There's a number of help things, and there's a SciFinder help near the bottom that you can use, Web of Science. So I put this here for my own purpose, but it's for you to use as well, where to get help. Here's the SciFinder CS customer service, the email, and a phone number that you could phone, and they can help you with that as well. So here's Unsplash. I use Unsplash all the time. So if you've never used it, where to get images that you can cite and that are copyright compliant. So you can use these. And so if you're happy, I'm happy. If you're unhappy, come talk to me. You may think of a career in chemistry. It's difficult, yeah, but it's fun. It's quite challenging and exciting, but it opens so many doors to other things as well. Even if you start with chemistry and move to other areas as well. There's a tab on the chemistry page, Careers in Chemistry, for Career Zone and resources by chemistry societies. But there's books that we've acquired that you want to look at as well. And browse through maybe an article or a chapter that may be of interest if you kind of thinking chemistry or you don't like chemistry, you want to know more about it, but it's an interesting resource page as well. So Careers in Chemistry. So there you go. If you need help, look at the Alta videos, look at the sample page for Professor Pilkington I put together to give you a guide, and make sure you check out the other SciFinder video. If not, good luck with your assignment.